Hello and welcome to the 2004 number 4 problem for AP Statistics. I'll try to go through the solution here for you. Starts off with two different antibiotics, A and B, and one has a cure rate of 60%, the other one has a rate of 90%. The one with 60% is cheaper, $50, and the one with the 90% cure rate is a little more expensive, $80. So they're trying to analyze this. What should you do if you're a doctor? What would you recommend to patients? If you're a patient, what are your choices going to be and what makes sense for you, kind of thing. It's a really good problem. I like this problem. Okay, so they work independently of each other. This is important. If they don't tell you this, you would probably have to figure that out on your own and make sure you kind of talk about that. Um, there's a bunch of kind of things here. It's all about ear treatment for ear infections on children, right? And they say you can use it on children. It's blah blah blah. The main point here is you have two plans. So a doctor might think, well, let's treat them with the first antibiotic because it's cheaper, and then if it doesn't work, then we'll give them the more expensive one afterwards, right? So you want to think about that. And then plan two is, well, let's give them the one that works better, right? Because this one has the better percentage effectiveness. So let's give them the good one first, even though it's more expensive. And then we probably won't have to give them the second one. But if we do, we still can. And we can try and give them the second one and see if that helps, right? So these have got two plans. And so our first task is to try to analyze those. So if a doctor treats a child with ear infection using plan one, what's the probability that the child will be cured, right? So plan one is antibiotic A first, antibiotic B second. And then we're also going to do plan two. So we're just looking, what's the probability that they'll be cured for both plans? If I were you, I would pause the video right now, try to draw this out. And if it was me, I would draw a tree diagram. You don't have to. You can do this without drawing the tree diagram, but I really love to do that on problems because it helps organize my thoughts and my solutions. Maybe this one's easy to do without it, but maybe that tree diagram is going to help me when I do some of these more complicated problems sometimes. So it's a good habit to get into. Okay, so stop the video, draw your tree diagram, and then see if you can come up with a probability that they get cured. Okay, so after doing your tree diagram and coming up with these probabilities, you should have something that looks like this. Plan A, this is plan A. We're going to give them the treatment A, sorry. Plan one is treatment A first, 60% chance of working, cost $50. If it works, then we're done. We don't have to do anything else. If it doesn't work, 0.4% chance of happening, then we have to go to the treatment B, which has a 90% chance of working, and it costs $80, right? So probability of it working, well, there's like, if you add all these ends up, it should be 100%, right? 60 plus 36 plus 4, that's 100%. So out of all the options, the options that give us a solution where the medicine was affected and the child was cured is the first one at 60 and then this 36. So you add those together and you get 96%. So 96% of the time the child will get cured, 4% of the time they will not, even though they've taken both medicines. Okay, for plan two, we're doing it in reverse. We take medicine B first, which costs more money, but it's 90% effective. And then we flip it, right? So you can see here that it's the same thing, but just flipped. And again, I'm just looking at what's effective. Well, there's a 90% chance it was affected here. There's a 6% chance it was affected here after going through B. And then you add those together to get your total probability. Obviously, they're the same. Like in your mind, it should make sense that whether you take the first one first, take A first and B second, or vice versa, it should work out the same probability. Well, it does. There's a 96% chance that we're going to cure a kid using both of these medicines. All right, now part B, though, now says, well, what about the cost, right? What's the expected cost for the two different plans? So again, pause the video, maybe use my tree diagrams or your tree diagrams and come up with what's the total cost, expected cost for each of these plans. Okay, should have gone through it, and let's go through it together. I'm going to show you the work down here below, but looking at the tree diagram, it really does help me. It's like, okay, here there's a 60% chance of just spending $50. Like, forget about the effective or not effective kind of, but there's a 60% chance of spending $50 because it worked and I don't have to take medicine B, right? But there's a 40% chance I'm going to have to go buy medicine B as well because the medicine A didn't work. So that would cost me $130. And there's just a 40% chance that I'm going to have to spend $130. There's a 60% chance I spend $50 only. All right. When I look at plan 2, then I'm going to have a 90% chance I'm going to spend just $80 and be done with it because it worked. But there's a 10% chance I spend the $80 and I have to go buy the other one for another $50, which again is $130. But now our percentages are a little different, right, for the numbers. So let's see what the math comes out to be. All right. So on the first one for plan 1, it's a 60% chance of spending $50 and a 40% chance I have to buy both. So that works out to $82. For plan 2, there's a 90% chance I spend just $80 on the medicine B and I'm done, but there's a 10% chance I have to buy both. You do the math, you get $85. So actually, even though they have the same probability, right? There's a 96% chance of curing a kid. There's the expected value for them is a little bit different. For plan 1, it's $82, a little cheaper, right? And for plan 2, $85. It's not a lot of money, but the point is maybe there's some treatments out there in the world that it really would make a big difference, some kind of, and you don't want to spend the big money on right away. You want to wait to see if the cheap one works first, so what's the better way to go? So this one, plan 1 would be cheaper. So this is the plan that usually we would recommend. Why? Well, it's the same probability of working, but this one would be cheaper, right? So as a doctor, you would recommend plan 1. And that's what question C is. What would you recommend? Well, I would recommend plan 1. They have the same probabilities, but plan 1 is cheaper. So why not go with that one? Okay, and that's the end of the problem. Thank you very much.